Hello, and welcome to this film, which is all about isotopes. Now, we've been learning quite a lot about subatomic particles lately, and that information is going to come in useful here because we're not only going to try and learn about what isotopes are in this film, we're also going to try and use numbers from the periodic table in much the same way we have done before to try and figure out how many protons and neutrons and maybe even electrons there are in some isotopes. So let's start off by having a look at a couple of isotopes. Now, you might remember seeing these two isotopes in a previous film. They're isotopes of carbon. How can we tell? Well, not only because we've got the symbol for carbon here, this capital C, but also because we've got the number 6 down here. And how do we know that this number is 6 other than by looking at it? Well, because it's carbon. Carbon is defined by the fact that its atomic number is 6. That is to say that every single carbon atom has 6 protons in it. And if it's a neutral atom, it's also going to have 6 electrons because protons and electrons are equal in a neutral atom. But there's a very important difference between these two atoms as well, and that is the mass numbers. So these two atoms of carbon are isotopes of carbon because their atomic numbers are the same, but the mass numbers are different. So let's now have a look at what the definition of isotopes is. And it's a really important one to note down, and it's important to remember because you could get asked to define this in a test. Okay, so isotopes are atoms of the same element, and remember we're defining an element by what its atomic number is, but with different numbers of neutrons. So once again here, it's highlighted on this diagram for us. The atomic number is the same for all three of them. We've got actually 3 isotopes of carbon in this diagram, but their mass numbers are different. And what does it mean if their mass numbers are different? Well, we should know by now that the mass numbers are the sum of protons and neutrons. If the atomic numbers are the same, then the number of protons must be the same. If the mass numbers are different, that tells us that the number of neutrons must be different. Now, how do isotopes affect the numbers in the periodic table? Well, if we have a look at carbon, say, because we've been quite focused on carbon in this film so far, we can see that what looks like it might be the mass number, the bigger of these two numbers, is actually 12.01. And that's because there isn't only one isotope of carbon. As we've just seen in the previous slide, there's 3. One's got a mass number of 12, one's got a mass number of 13, and one's got a mass number of 14. And some are more common than others, and the fact that this mass number is so close to 12 tells us that the isotope with a mass of 12 is the most common one. But this number is like an average of all the other mass numbers. And so the 13 and 14 isotopes come into play here. So that's the reason that we don't get whole numbers in some periodic tables for the mass numbers. Okay, you'd think they might have to be whole numbers because protons plus neutrons has to be a whole number. But when we get these decimal numbers, it's because they're an average of the mass numbers of the different isotopes. Now, as we've seen before, we're going to keep things simple for now in year 10. So we use this periodic table, again, focusing on carbon here, where the mass numbers are rounded to the nearest whole number. So we're not worried about all these different isotopes and how they average out for now. But it is important to realise what isotopes are and what effect they have on numbers in the periodic table. Now, here's a couple of quick questions, as usual. Check that you can answer them and pause the film if you need to. Here's the answers. And as usual, I'll just remind you that if these things aren't clear at this stage, it's good to go back and try and clear them up in your mind before you move on. Now let's have a look at an example problem. Okay, we're told here 2 isotopes of oxygen. Now oxygen is here in the periodic table. Okay, it's got an atomic number of 8. The smaller number is 8. It's got a mass number of 16. 2 isotopes of oxygen, so these aren't the only types of oxygen atoms, there's other ones too. 2 isotopes of oxygen have mass numbers of 16 and 18. How many neutrons does each one have? Well, let's see if we can remember how we find the number of neutrons. The number of neutrons is equal to should remember that it's the mass number, A, minus the atomic number, Z. Okay, so in this case, we've got two different isotopes. In one of them, it's going to be 16 minus 8. So the atomic number never changes because we're talking about oxygen. So we'll call this one part 1. And in part 2, we're talking about another isotope where the mass number is 18. And we're still going to subtract 8 from it because the atomic number is always the same. So in the first isotope, we should have 8 neutrons, and in the second, we've got 10. So again, highlighting the fact that these isotopes of oxygen, they've got the same number of protons, same atomic numbers, but different numbers of neutrons, which leads us to these different mass numbers. Here's another example problem, and we've got to write the symbols here. And this is, I guess, to revise the way that we write symbols if we're writing them by hand instead of in the periodic table. Two isotopes of chlorine, so we're talking about this element here, okay, one of which has 18 neutrons and the other of which has 20. Now, chlorine has the atomic number 17, so when we write the symbol, we're always going to write the atomic number down here, remember, bottom left. If it has 18 neutrons, what's the mass number going to be? Well, it's the sum of protons and neutrons, so 17 plus 18, that's 35. So one of the isotopes has this symbol. The other one will also be chlorine, so it's still Cl. It's always 17 down here because all chlorine atoms have 17 protons. That's how we define them. Okay, but this one's got 20 neutrons. 20 plus 17 is 37. So there's the symbol for those two isotopes. Now, what we were trying to do in this film was understand what isotopes were and to find the number of protons and neutrons in isotopes. We also talked about electrons. Remember, if these things are neutral atoms, the protons and electrons will always be the same as one another. Protons and neutrons don't have to be the same, and hopefully you understand how to make these connections. As usual, it's really important you see your teacher if there's anything confusing here, because you want to be able to move on and feel comfortable with the things you've done.